Hello guys, it's teacher Yolanda here. Welcome to our session 13 of our classes. For this class, we're going to need our content areas notebook, okay? So please go and get it. Here it says, let's do some counting. How many hexagons are here? So let's do it. This is 1, 2, 3, 4, 5. But what if there was just part of an hexagon? Just a part, look at it. How would we count it? We'll use fractions. Fractions are for counting part of something, okay? For now, we're going to see that a fraction is just a little part of something. Here it says, let's break the hexagon into 6 equal pieces. So all of these are equal pieces. What if we just had one of the pieces? This one. That would be one piece out of 6 pieces, right? Here's how we write it using fractions. One piece, which is this part, out of 6 pieces, these other 6. The top number, it's called the numerator, and the bottom number is called the denominator. And how are we going to read it? We read this 1/6. What does it mean? Well, it means that we're going to use ordinal numbers. Do you remember? You have one summary about ordinal numbers here in your content areas. Why don't you look for it? I'm sure you can find it. Let's do some more counting. How much of this hexagon is red? Now we have 1, 2, 3, 4, 5 pieces. 5 pieces are red out of 6 total pieces. So that means that 5/6 of the hexagon is red. Only 5 pieces out of 6 in total. Now let's do the opposite. How much is blue? 1 piece out of 6. So 1/6 of the hexagon is blue. Here it says, what fraction or part of this hexagon is red? Here we have, it's 6 parts out of 6. All the hexagon is red. If you said all of it, you're right, but your answer isn't a fraction. 6 pieces out of 6 pieces are red, so that's 6/6. This is the whole hexagon. What is whole? Entero. So it's one whole hexagon. So how do you say entero in English? Whole, a whole or one whole. So 6/6 is the same as one whole hexagon. 6 is like a magic wand. You'll see why later. You'll be able to do lots of magic wands, especially in algebra. That's something that you will start seeing with teacher Gabby at some point. Here's some more. We have 7/7, 15/15, 2 halves. Pay attention, I didn't say 2 twos or 2 seconds. No, I said 2 halves. And we have 1,234, 1,234ths. Can you hear? I said ordinal number. When the numerator equals the denominator, it's a magic one. That means a whole. It's complete. Now we're going to talk about something here. We're going to start talking about improper fractions. Let's read this explanation. Here it says, actually, there's nothing improper about them. What is improper? Impropio. Yes. It's just when the numerator is bigger than the denominator. There is a mistake here, guys, so let's correct it. That is a mistake. The correct text would be 10, like this. 10. So it would be bigger than the denominator. Okay, here it says. So let's see what this means. Let's look at a hexagon. That's 7 pieces. That clearly is not a hexagon. So let's see, we have a complete hexagon and an extra piece. So we have one whole and one extra part of a hexagon. That means one whole, 1/6. So 7/6 must be the same as one whole and 1/6. These are equivalent fractions. Let's see how this works. Look at the hexagons again. 6/6 and 1/6. A 6/6 is a magic 1, so we have only an extra part. So with this one, we can say that 7/6 equals the 6/6 plus one part of a 6. So that is one whole hexagon and 1/6 of another hexagon. Now let's check some more fractions. What are these type of fractions called? These are called equivalent. You have seen them in your Spanish class. Equivalent fractions. Let's check out these circles. Look at it. Look at it. 1/2 of it is red. That means that we decided to divide this circle in two. So 1/2 of it is red. Here it says 3/6 is red. Yes, because this circle is divided into sixths. So the first one says, and 1/2, pay attention, this is half, 1/2 of it is red. And the second one says that 3/6 is red. But the same amount is red in both circles. So 1/2 must be the same amount as 3/6. And that's true. They are equivalent fractions. How can we verify this? Because they are multiplied by 3. 1 times 3 is 3. 2 times 3 is 6. These are called equivalent fractions since they are equal amounts. Look at another one. Here we have two rectangles, but look, the same area is colored in green. But here we decided to divide it into 3 parts. So that means that 1/3 of it is green. Pay attention, this is a third. Like first, second, third. 1/3 is green. And here we have 3/9 is green. Why 3/9? Because this is divided in 9 parts. Let's check 1, 2, 3, 4, 5, 6, 7, 8, and 9. 3/9 of it is green. The same amount is green on both, so they are equivalent fractions. So that means that 1/3 equals 3/9. Let's see if we can check it also by doing a multiplication. 1 times 3 is 3, and 3 times 3 is 9. Now, let's pay attention to these things. Making fractions is not only a part of one thing, it can be also making parts of groups, of totals of groups. For example, here it says, so basically a denominator is how we decide to divide a whole, or also how we make groups. So a denominator is how we divide something or how we make groups. Let's use the denominator for making groups. Let's use these balls to make a fraction with the denominator 3. That means we have to make groups of 3. So pay attention. 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3, and we have 2 extra ones. They are not enough to make a group of 3. So we have 6 groups of 3 balls and 2 extra ones. These would be represented like this: 6 groups of 3 and 2 extra ones. 6 whole groups of 3, the number of items in a group, and the 2 extra ones. How would we read this? 6 wholes, 2 thirds. Okay? I'm going to repeat it. This would be 6 wholes and 2 thirds. Okay? Now let's pay attention to this one. Now let's do a denominator too. What does that mean? That means that we have to make groups of 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 halves. I am going to write it here. They are going to be 10 halves. Pay attention, the plural of half is halves with a V-E-S, 10 halves. Now, here it says, now a denominator 7, so we're going to make groups of 7. 1, 2, 3, 4, 5, 6, 7, one group. 1, 2, 3, 4, 5, 6, 7, another group. And 1, 2, 3, 4, 5, and 6 extra ones. So we have 2 groups of 7 items and 6 extra ones. How would we read this? They are 2 wholes and 6 sevenths. Okay, that's how we would read it. Now let's pay attention. We have all of the groups that we made in the previous pages. So all of these are equivalent fractions. Why are they equivalent? How is it possible that 6 wholes, 2 thirds, 10 halves, 2 wholes, 6 sevenths are equivalent? All of these are equivalent because they all have the same number of balls, 20. They are exactly the 20 same balls. The only difference is the denominator. But what's the meaning of a denominator? Remember, the denominator is how we decide to make groups. That's the most important thing. A denominator is how we make groups or how we divide an object. For example, each color of the balls represents 1/4 or 5/20. Can you see it? Why? Well, if it's 1/4, that means that we're going to divide our groups here into 4. So 1 group, 2 groups, 3 groups, and 4 groups, each color. Can you see? The red is only 1 out of 4 groups of colors, and they are all exactly the same. Now we have to make another one. It says 5/20. Why 20? Because they are 20 balls in total, and only 5 of them are 1 color each. So let's pay attention. 1, 2, 3, 4, and 5. 5/20 are red. How would you spell that? It would be 5/20. Remember, we're using ordinal numbers for the denominators. Now, how can all of these be equivalent fractions? Is there a way to check it without making drawings? Yes, of course, there is a way. Here we have 6, which is a whole. It says first multiply these. So 3 times 6 equals 18. So these are 3 times 6, 18. And now we're going to add the extra 2. So 18 plus 2 equals 20. Now let's do all the operations here with our fractions. Here we have 3 times 6 equals 18 plus 2, 20. Now in here we would only have to do a multiplication. 10 times 2 is 20. Now 2 times 7 is 14 plus 6, 20. Can you see? We can verify that all of these fractions represent the exact same amount, 20 balls. So here it says that we have some special spellings. Remember that you have a summary on ordinal numbers in your content areas notebook. So here we have 1/2, 1/3, 1/5, 1/9, 1/12, 1/20, and 1/40. Remember to study the ordinal numbers so you can do the exercises of today's class in our PDF file. And as usual, last but not least, please do the exercises and write down all the doubts that you may have about them. And we'll see you today in our Zoom class. See you. Bye.